Okay, for today, I'm going to have you start by just finding the inverse of the one I have circled here. It was not one of the circled problems, so I'm going to give you a second to give that a try. Okay, so let's see if you did it right. First of all, x and y have to be reversed, so this becomes x equals y minus 2 over 3 plus 4. And then I solve for y. Remember me saying that the first thing you should do is fix fractions? Clear the fractions. If you haven't caught on to that, that's a big deal. It's going to happen a lot. I'm going to times everything by 3. This part gets times by 3, and this part gets times by 3. And this becomes 3x equals, that 3 cancels that 3, y minus 2 plus, and 3 times 4 is 12. You got to do that right. Got to learn how to clear fractions. Now I'm going to put 3x together, and I have y, and then those two can go together, plus 10. Now I just was trying to get y alone. It gets kind of confusing sometimes, like what am I trying to do? Trying to solve for y. So I'm going to take away 10, final answer. I'm going to reverse these. I shouldn't do that. Y equals 3x minus 10. And then I always like it to be better if the y equals is on this side, so I'll do that. Okay. Any questions? Now, how could you prove those really are inverses? One thing you could do that wouldn't prove anything but would kind of make you feel better about it is if you found a point that worked on this one, and it turned out like 2, 5 worked in there, do you get that then 5, 2 should work in the other one? Get what I'm saying? X and Y have been reversed, so you could check a point, but checking a point doesn't prove that you've totally got for sure inverses. But if I take this and I take this, my two functions that are supposed to be inverses of each other, and I do f of g of x and g of f of x, they should equal x. They should both come out to x. And I know it may seem like I'm speaking Greek here, but if I make this one be called f of x, and I make my new one my inverse, and I call it g of x, if I nest the functions in each other, f of g of x and then g of f of x, they should both come out to x. All right, so I got to memorize that. X minus 2 over 3 plus 4, and 3x minus 10. X minus 2 over 3 plus 4. That was my f of x. And then g of x was much simpler. It was just like 3x minus 10. Did I have that right? Okay, cool. I have a short-term memory. Sweet. All right. Now, how do I prove it? Here's how you start your proof. If inverses, then f of g of x equals g of f of x, which should equal x. F of g of x equals g of f of x, which has to equal x. You can't just prove that this equals this. That is a common mistake. People just think, oh, I'll set them equal and find out if they're really equal or not. They have to simplify down to just be x, and I think you'll see it'll work pretty well. Okay. First, let's find f of g of x. Would equal, here's the f function, and it's going to eat the g function. So I'm going to make an empty spot where the x is, and I'm going to make it eat the g function. Okay, what's the g function? The g function is 3x minus 10. There. The f function ate the g function. Now, from what I said before, do you remember what this should simplify down to? Just x. Let's see if it really does. Now, would you agree that this is 3x minus 12 over 3 plus 4? And I'm supposed to be simplifying it down and showing it equals x. Then I'm going to say, oh, the 3 factors out. and I have x minus 4. And you might say, why would you know to factor that? Because if you can factor it, you should. It's a favorite saying for a reason, because it comes up in here so much. And now why did I factor it? Because now I can cancel this. And now you can see pretty quickly we're on our way to getting it down to just be equaling x. X minus 4 plus 4. And one common mistake people make is they go, oh, cancel, cancel, and then don't try to do 2 steps at once. Okay, then you're not following the order of operations. You can just do one thing at a time. So I canceled the 3's. And now plus 4 and minus 4, of course, cancel. And I've showed that f of g of x came out to x. Am I done? Nope. You also have to show that g of f of x will come out to x. So that's our next step. Would you do this one from start to finish? G of f of x. Scroll up, figure out what g of f of x would be. Well, here's the g function with a big empty spot. And then I'm going to make it eat the f function. X minus 2 over 3 plus 4. Now, as I multiply this in, do you get to this 3 times this part? The 3's will cancel. And then I got to distribute the 3 over here to the 4 also. Okay, so this will be 3. Oh, the 3's canceled there. So it'll be 3. It'll just be x minus 2. Sorry. Here, I'll write out what I did. There. I multiplied this, distributed the 3 out. Then the 3 cancels. And then I have x minus 2 plus 3 times 4 is 12. Minus 10. And that's x minus 2 plus those 2. Actually, I should do it from left to right. So I'll do it from left to right. And the minus 2 and the plus 12 will make x plus 10 minus 10. And that's just x. Cool. Therefore, and you have to, when you're proving something, you have to summarize it with a final statement. What just happened? Okay, so you can't just end with x. Therefore, f of g of x was equal to g of f of x, which was equal to x. Okay, we just proved 2 things. We're for sure inverses. And so I'm going to include one more. Do you guys know what the 3 dots in a triangle means? Shortcut for therefore. You can either write out the word therefore. They are inverses. Remember, the whole point was to prove that they are inverses. So you should end a proof by saying, therefore, I've proven what I wanted to prove. I've proven that they are inverses. All right, I'm going to give you 2 simple functions. And I want you to prove that either they are or that they aren't inverses. F of x is 2x minus 7. And your friend, I'm going to make sure it's clear that that's a 7. And your friend has got an answer, and you want to prove that they're either right or wrong for the inverse. They say the answer is 2x over 7. Prove that either they are inverses or that they aren't inverses. I'm going to pause for a second to give that a try. So a student came up and typed this, or wrote this, sorry, on the board, and they put the one function in the other function, Now, I can't tell whether they did f of g of x or g of f of x. It would have been nice if they'd said that they were doing the one or the other. It looks to me like they did f of g of x. Was that? No? Was it g of f of x? Okay. All right. G always. Okay. G. Yeah, you're right. G of f of x is what he was trying to show. And then he's got the f function being swallowed by the g function. And that means, there it is inside the stomach. Okay, good. And he multiplied it all out, and it basically didn't simplify down to x, so he knew right away. Now, what if it had simplified down to x? Then there's the second part, and he would have had to go do what? F of g of x. All right, good. So for this next one, I'd like you to take this function, f of x, which is equal to 5x over 3, and I'd like you to find its inverse, and then prove that you are for sure that it is the inverse. So in other words, first find the inverse, then prove that, I think you should call your inverse g of x, then prove that they are inverses. Okay, so I'm going to get help from Dice of Destiny to see who's going to do this for me. Row 2, person 5. Man, it really wants to hit you, Count, but it didn't. Yes, that's you. You don't have to come up, just tell me. What did you get for the inverse? When you swapped, you said y equals 5x over 3, and then you switched to places. What did you do then? You solved it down for y, and you got? All right, 3x over 5. Can anybody verify they got the same thing as she did? All right, good. And now, how do you prove that you've got the inverse there? F of g of x, which in this case, if I start with the f function and make it swallow the g function, then what did you do now? Oh, okay. All right. So I'm going to help you from here then. I'm going to need to make this show that it equals x, right? Remember me saying, can I just do that? Is that like mathematically sound? No. I can just do one thing at a time. Would it be okay to multiply this in right here and see what happens? Sure. And then those 5s will cancel, and then I'll end up with 3x over 3. And then, can I cancel those 3's? Yes. Just make sure you show your work. Yay, it equaled x. Okay? Now, maybe it'd be nice to put this in like a 2-column form. You do not have to. But I would say, okay, now I'm going to over on the right side. You know, maybe I should have done this down. Actually, let me see. There. I got x on the left side. Now I'm going to, over here, figure out g of f of x. And that one's going to be g, and then eats the f. Man, that feels a lot alike, but I guess it is a lot alike because the fractions, they're both fraction functions there. So that cancels that, and now I have 5x over 5. And yeah, it is different, but it's still going to cancel, and I get x. Yay. And therefore, I guess I could say f of x and g of x are inverses. Okay, you learned how to prove two things are inverses. What else, since today is kind of a review day? It's a review day today and then part of tomorrow. But part of tomorrow is going to be 20 minutes on the top 20. All right, so make sure that you're ready for that. But what else do you think we should review? I don't want to just say, here's all the test questions. I'm not willing to do that. But what do you think could be on the test? And then I'll do one like that for practice for us. You know what we've studied for the last 3, 4, 5 days? What type of a question would you expect would be on the test? And I'm not going to verify if it is or it isn't. But, yes. Can you just repeat the sequence of F's and the G's and stuff? Ah. Ah, yes. Okay. So here's a simple one. I agree. Let's start with that, and then let's move to the divide kind. Let's say f of x is 2x minus 7, and I'm going to force it to have a domain of x is greater than 1, even though it normally wouldn't have that domain. And then I'm going to say g of x is equal to the square root of x minus 4, and you got to figure out its domain for yourself. Then I'd like to know what is f times g of x, and hint, you cannot mix square roots and other types of functions. So therefore, you're just going to put them next to each other. What's f of g of x, and what's its domain? That's a good practice problem. I'll pause for a second while you give that a try. Okay, let's just take f times it by g. Do you get why putting parentheses around that square root would kind of be dumb because they're already grouped? Okay, so grouping symbols are important. If I threw in an extra parenthesis, would I be wrong? No. If I left off that parenthesis here, would I be wrong? Yes, I would. Because otherwise, you'd be implying, think about it, if I remove them, you'd be implying that 2x minus 7 is going to just, the 7 is going to get times by x minus 4. You know what I'm saying? So you leave off those parentheses, I have to mark the whole thing wrong. All right, next, do I actually distribute this out? No, I told you can't distribute into a like square root, so we're done. Now we just have to find its domain. I have to have the domain of f and the domain of g, and I'll see where they overlap. Domain of f was given to me right here. Normally this would be all reals. You can't crash that thing, so it would have normally been all reals, but they forced it to have this, called an artificial domain. And here's one, and it's bigger than one. There. And then the other one, this one you have to know how to solve. You have to say, take what's underneath here, x minus 4, and set it greater than or equal to 0. Therefore, x greater than or equal to 4. That's the domain for that guy. So here's 4, greater than or equal to 4. And where do they overlap? They overlap right in there. So you'd say from 4 to infinity. And again, I probably, since you've done all this work and the only thing you did wrong was a little thing, I probably take off only 5% on the test for that. Instead of, normally if you miss one of the big 4 problems, you lose 10%. It knocks you down from an 85 to a 95 to an 85. That's all it would take. But I would probably only take off 5% if it was just the bracket versus the parentheses. How many of you had a bracket? Excellent. Okay. Do the details matter in math? Totally. Did I tell you about the Mars mission? Here's another one I like to remind people. Like sometimes people get really annoyed about, I just forgot the negative. Well, they did a Mars mission where they sent a satellite that should be revolving around Mars, taking amazing pictures of Mars all the time. And they sent it up there, and it cost like billions of dollars. And one guy made one mistake on one calculation, and it was a feet to meters conversion. He forgot that it was meters versus feet. And again, that's partially because the United States is like the only one left major country that uses feet. Okay, otherwise it would have been in meters. Well, anyway, and it made the orbit of the satellite instantly go too low, and then it crashed. Like they got it all the way there, and then they started to put it into orbit, and because there was one calculation done wrong, it crashed. So all of that work, and it takes years to just get it there, and then it crashes because of one mistake, one equation. So yeah, math's picky. Sir. Yes. So basically, let me talk about what would happen if we made this a divide problem first, though. Okay, so let's say this became a divide, and I go divide by g. Instead of times g, it's going to be divide by g. So f divided by g. Why am I leaving the other ones up there? Because I still need these two number lines, right? When you divide two functions, there's a third thing you have to consider, and that's that now, what's special about g now? Yes? It can't equal 0. Very good. So if g can't equal 0, which before it was okay if it was 0, now how could we make that turn into a 0 and thus crash the whole thing? With a what? A 4. A 4 would make it crash because a 4 would make it 0, and a 0 on the bottom of a divide problem would crash it. So you have a new number line, and that's the number line that you don't want g to equal 0. G not equal to 0. And then you ask yourself, what would make it 0? 4 would. Here's a 4. I make it an empty circle. And from this thing's perspective, it only cares about what would make g 0. So the only thing that would make it 0 is negative 4. And therefore, now I see where all three overlap, and the answer does change. Yoink, take off that square root, or sorry, bracket, and there's my answer. They now overlap there. That's the difference. It's just a bracket versus a parenthesis, because those three number lines now all overlap at bigger than 4. Okay, now somebody asked me about the difference quotient. Here is, this would be a pretty simple one. How do you do a difference quotient of that? Well, first of all, do you remember what it really finds? Slope. So tell me the answer. 2. If we do difference quotient on this, it's just going to find the slope, and it's just going to come out to 2. Okay? So let's make one that's a little more complicated. Okay? Let's say it's 2x squared minus x. Now, find the difference quotient. Now, I told you wouldn't have to memorize this, but I bet you some of you have. F of what? F of h? X plus h? And then what? Minus f of x all over h. Good. That is the difference quotient. Find it for this equation. Okay, so if I'm going to start this, I'm going to put x plus h into this and that, and it's going to take me a while, so you guys are ahead of me now, so I'm going to start. You may not be finished yet, but I'm going to at least start. So I'm going to have 2 empty spot, x plus h squared. That's just taking this part here. And then I'm going to subtract x. I can't just put an x there. I got to put x plus h there again. Basically, x plus h needs to go here and here. Now it's 2 x plus h and another x plus h minus x plus h. A lot of grinded out kind of math here going on. X squared plus 2hx plus h squared. And then minus x minus h, I distributed by negative. Multiply everything by 2. 2x squared plus 4hx or xh, doesn't matter, plus 2h squared minus x minus h. Whew, that's messy. But that's it. Raise your hand if you got the same thing as I did. Okay, awesome. If you're a little slower at the multiplying it all out, you'll eventually get there. Now I got to do this, minus f of x. So that's the original function. So minus 2x squared minus x. Minus 2x squared minus x. Now I just made a tragic mistake right there. And it's a really common one. What'd I forget? Yes?
You forgot to put the negative into the negative x.
Yep. I'm going to say I forgot parentheses. And that way I would get the negative to distribute to both parts, just like you just said. Yep. Get what I'm saying? This should really be negative 2x squared minus x or plus x. That negative has to distribute. All right. So now that, I guess I can rewrite everything. 2x squared plus 4hx plus 2h squared minus x minus h. There. Okay, now this and this will cancel. This and this will cancel. And so I'm left with all of that. And don't forget, I still have to divide it by h. So I'm dividing everything by h. And all of these canceled. Now, if you can factor it, you should. Yes, find a mistake in there?
It's the 2x squared, not the 2h squared.
Thank you, thank you. All right, I'm gonna, how do I fix that? This is getting canceled, but not that, so I'm gonna like scribble that out. Thank you. So now I'm gonna rewrite it to clean that up. 2h squared is still there, it did not cancel, plus 4hx, and then I have a minus h all over h. And it's happened already this lesson. What's this key? Factoring. Got to factor out the h. That has an h in everything. H comes out, and it's all over h. H comes out of the top, and you'll have 2h plus 4x minus 1. And now those h's can cancel. Final answer, 2h plus 4x minus 1. Now that's a complicated slope. That implies the slope depends on some stuff. Maybe since you're getting better at this, you can get the idea that if this is a curve, we're finding the slope of a curve. The slope of a curve would depend on x, like where you started. Like if I start at x equals like 3 or 4 or whatever, it'll depend on that, right? And if I start there, what's the slope? Well, it depends on h, which is how far over you go before your next point. And if I say h is like 3, I'm going to go over 3 spots and then take that. Then my slope will be depending on x and depending on h. Now, you don't have to know all that for the test. All you'd have to know for the test is that that was the answer. And that's just some icky algebra that we make you know how to do. Okay. One more kind with icky algebra if we have time. Actually, let me show you your homework. Let's get into the homework. Everybody look. I warned you that last night would be the easy night, not much homework. Tonight would be a little more difficult. This is the beginning of the assignment right here. Okay. And I don't think we need to do this stuff that involves the calculator because you're not going to be able to use the calculator in this test anyway. So I'm going to have you skip those. Let's focus on this. Not the challengers. Forget that. Let's focus on this. Okay. Now, this is something we didn't do much of because we were focused on finding the inverse algebraically. Do you remember how to do it with a graph? It's a reflection. As a hint. What do you do again? Reflect it over the line y equals x. So if you wanted to, it'd be smart to, on all your graphs, make a dotted line like that. And you're going to have to reflect it across that line. Let's look at that one for a second. That's kind of unique. What's special about C? Yeah, when you reflect it across that line, it's going to be the same thing. Its inverse is itself. Are there any numbers that are like that, where the inverse of the number is itself? Yep, the number 1. Because the inverse of 1 is 1. Okay. All right, dotted line like this. So you're going to be sketching these, and the last ones get pretty wicked. Now, one more thought. Do you get, if this is the point 0, 1, that if you're doing an inverse, then that means the point what, what must be on the inverse? If we start with 0, 1, what do we get? 1, 0. Because x's and y got switched. Remember? 1, 0. That spot is on your graph, guaranteed. I didn't quite make it far enough because if that's 1, then I got to keep it comparable, right? There. That's on your graph. How about this spot? That's what, what? -1, 0. You should know that that's the x-axis, so its y is 0. Negative 1 comma 0 would go with 0 comma negative 1. So that point, again, has to be a point on your graph. It really helps to like just do little parts at a time like that. Okay, now if I can start figuring out how to, okay, well this would be kind of like this. Well, it has to go through that point, and then it kind of ends there. Oh, cool. There we go. I did my inverse. It's a reflection across that dotted line of y equals x. All right, and then these are really important. We just added them today to the assignment because we felt like we didn't have enough of those, so they're important. That one and that one. All right, so we start here, and we just have that and that. Still pretty light assignment, which is good because what's happening tomorrow? Step 20. I encourage you to do a practice one tonight. You could be all dialed in, know exactly where your weaknesses are, and fix them because there's a link to the videos for it too. So, all right, that's all I got for you for today.